Welcome to SteelCast. This is Tata Steel UK's podcast where we talk all things in this series about decarbonising the UK steel industry. We've talked to politicians, we've talked to academics, we've talked to customers, we've been to events, we've talked to people inside the business, we've talked to lobby groups, and we've talked to people outside the business in the industry. Today we've come to Marine Power Systems in Swansea. This is a company who is just receiving some Innovate UK funding to look into developing their floating windshore foundation structures such that it could use more strip steels from Talbot Steelworks and more green steels once the electric arc furnace is built. So without any further ado, let's meet some of the guys here. So when people talk about the decarbonisation of the steel industry in the UK, their first thoughts obviously go to the technology that we're likely to be using. So electric arc furnace, moving from blast furnaces and basic oxygen steel making to electric arc furnaces. And all the implications that go with that in terms of the site layout, the configuration, the grades we can make and the customers we can serve and so on and so forth. The implications of moving to electric arc furnace technology in terms of the operational footprint and the number of people employed in a business of that size are obvious, and those are some of the discussions we're going through at the moment. A lot of people are starting to raise their visions by a few degrees and look further into the future, especially in the Port Talbot region, about the potential of that region to become an industrial ecosystem with steel, a green steel hub at the centre of it, attracting inward investment and being at the centre of some of the renewable aspirations of companies on the doorstep. And so that's the topic we're going to start touching on today, because whilst people might talk about green jobs as being this sort of ethereal concept, some of this stuff is actually starting to come into reality. So we've come to Swansea today, and I've got a couple of people to talk to, but before I go on to talk to the guys from Marine Power Systems here in Swansea, I just want to first talk to Cam Rajput. Cam, thanks very much for joining us. Cam is Strategic Business Development Lead for Tata Steel. Now, you've been living in this space of this industrial ecosystem, this future vision for some time now. Talk to us a bit about what that looks like in your mind, or could look like, and some of the progress that's already been made.
Yeah, thanks, Tim. I think I have been involved in the projects and the sector now for probably about 18 months to 2 years, and it's absolutely fascinating. And I think what my vision and what the vision I want to share with stakeholders, both internally and externally, is that of how you really eloquently put that industrial ecosystem where we've got steel being made, green steel being made in Port Talbot, processed and then utilised by organisations like Marine Power Systems for floating offshore wind structures. And those structures are then made using reduced embodied carbon in their offering, and then they're used and floated out into the Celtic Sea. And then those structures generate energy, which we may or may not use, but clearly as a high energy user, it allows us an option to do that. And then we roll out 20, 25 years or even further, where these structures then get decommissioned. Yeah. And then what that allows us to do is bring that structure back with supporting colleagues around us and actually recycle that steel back into the arc furnace. So the vision for me really is to develop a proposition with partners where the steel that is used for these structures in its entire life doesn't travel more than 10, 15, 20 miles.
Yeah, and it is a complex picture, because as the site configuration of the Talbot Steelworks changes, there'll become a lot of land available as the blast furnaces go, and the steel plant and the coke ovens and the sinter plant. And I guess people's worry is that you're going to get call centres and Amazon warehouses. And I know you talked there eloquently, and we're going to come on to talk a bit more about the floating offshore wind options in that area. But you've got the Celtic Freeport in Port Talbot and Milford Haven that provides some opportunities, ABP, Lanzatech, and these were just names a few months ago of people who might be interested. But some of that's starting to come to fruition. It's not just floating offshore wind, is it?
No, absolutely not. And actually, most recently, ABP have been successful in securing some FLOMIS seed funding, which is going to allow them to begin the upgrading of the port facilities to enable this type of fabrication and assembly take place. And the other point you touched on earlier is what we need for the creation of jobs, the creation of economic growth, is to attract inward investment into the region to enable this fabrication and assembly to take place. What's really important, though, is that we work with stakeholders like Marine Power Systems at this very early stage to ensure that our steel can be used within these types of structures, and we don't suffer what we have suffered as a UK PLC over the past 25 years with fixed bottom offshore wind, where all of that manufacturing and all of that assembly takes place outside of the UK, and we have imported products and components being deployed here in UK waters.
Yeah, and it is a complex issue, and the reason we've come to Swansea today, and I'm going to bring in Graham Foster, Chief Technology Officer, Marine Power Systems here. The reason we've come to visit you today, and thanks very much for having us here, is because Innovate UK and their Launchpad programme have put some money towards the project that you've been working on, which is some of the platforms for these floating offshore wind structures, and the potential to use local supply chains and potentially use some of the strip steel coming out of the Talbot Steelworks. Tell us a bit about that project and what that funding is going to go towards.
Yeah, thanks, Tim. Yeah, it's delighted to have you with us in the office today. So we're developing Pelaflex, which is a floating foundation for floating wind projects. Our technology has a number of advantages over some front-runner technologies. It's lighter weight, it's more stable, and in the end, it's lower cost through using less materials and being easier to operate and so on. So lots of technology advantages baked into what we're doing, and it's uniquely suitable for the Celtic Sea, we think. Now, one of the things that this Launchpad funding has enabled us to do is involve local stakeholders, ports, fabricating companies, and crucially Tata Steel. And I've been, in discussions with Cam for a while now. We know each other quite well. But what we've identified is that if we take a little, another closer, harder look at how we design and fabricate our structure, then potentially we can incorporate a lot more green local steel. So we can really utilize the output of the new electric arc furnaces from Port Talbot. And at the moment we've identified, and this is similar with all other steel floating foundations, that due to the thickness and various requirements and limitations that are currently incumbent with what comes out of Port Talbot, there's less than 10% of the structure can be made locally, which isn't a great result if we're honest. It still means that even if we were fabricating structures at Port Talbot with the new port facility, not that much of the steel would be coming from literally a stone's throw away in the Port Talbot steelworks. So we know we can do better than that. So this Launchpad project, we're going to just go through the design in detail with the requirements from Tata, and our target is to get that less than 10% content of local steel up to well over 50%.
Yeah.
And we're very confident that we can deliver that, maybe more.
Yeah.
But that's the purpose of the Launchpad project, and that's why we're excited at MPS to be working with Cam and Tata Steel to make a difference to what can be done locally and the local supply chain and the thousands of jobs that are at stake here.
Yeah, it is a hell of an ambition, isn't it? And I know that when we talk optimistically about floating offshore wind, we've been doing it for a while, and the first thing that people say is, well, that's all very well, but you can't make the plate steels that are required for the tower of the wind turbines. But you're talking specifically about this platform, which we can see behind us, and we'll put some graphics on the screen about it. Because investing in a plate mill, we've just spent effectively all our money investing in an electric arc furnace. Investing in a plate mill might be another £1 billion, best part of £1 billion. So the opportunity to build these things using strip steels is a massive opportunity. But how far away do you think we might be? Because as I understand it, there's no sort of commercial developments of floating offshore wind anywhere in the world at the moment. How far away do you think we might be from starting to see these structures being fabricated using strip steel products?
I don't think we're as far away as as we think. The important thing to note is that these are long projects, that there's a lot of work needed, and it's a 10-year endeavour from conceiving of a project to getting equipment in the water. So right now, the major energy companies are applying for leases for the Celtic Sea. The same sort of thing has already happened in Scotland, and we're expecting deployments of the technology, with switching these farms on very early 2030s. So 2030 to 2032, something like that for the first projects. So that means that the work is already started, and in fact MPS is already working with the developers that are interested in the Celtic Sea. Now these developers are working with us because they know that we've got a product that really works well in the Celtic Sea. They know we're committed to the local supply chain, and so they see us as a really good potential supplier for these floating platforms. So that work has actually started. Everything is still subject to the developers winning the seabed, subject to MPS being part of a competitive process for their technology selections. But we're doing well. We think we're very well positioned, and with fingers and toes crossed, fully expect to be part of the mix out in the Celtic Sea. And of course, MPS is a Swansea-based company. We really have a commitment to the local supply chain, and we really want to work with Tata Steel. It's something that we're committed to doing, along with the other local suppliers. We don't want products coming in from all around the world if we can help it. There will be some global element to this, I'm sure, but ensuring a local focus, absolutely top priority for us.
Now, Graham, while I've got you here, it would be remiss of me not to delve a bit more into some of the more maybe simplistic aspects of floating offshore wind, because I'm slightly struggling with it myself when you were telling me that your aspiration, one of the aspirations to use strip products rather than plate products is to make the structure lighter. Now, in my world, I was expecting it to have to be heavy to weigh down what is a fairly massive tower. These things are huge, aren't they?
Well, the turbines that we're discussing with the developers now will be up to 20 megawatts in size and the height of the Eiffel Tower. So the whole system will weigh maybe 7,000 or 8,000 tons. These are very, very big structures. This is battleship size pieces of steel.
And there's a lot of them.
There's a lot of them, yeah. With all of the plans that the Crown Estate have got and the UK government have got for the Celtic Sea, it's well over 1,000 devices out in the Celtic Sea in the 2030s. So huge pieces of kit, huge opportunity for everyone involved. But fundamentally, what we're doing is we're just approaching it slightly differently. So our device is what's known as, or has its principles as a tension leg platform. So what we do is we pull a buoyant structure under the water, and it pulls up then against the seabed, and that tension keeps it steady against the worst possible wave and wind conditions. And it really is, it's one of the reasons why I say our technology is uniquely suitable for the Celtic Sea, is because that way of tethering the system just gives it much better stability. It's a much safer environment for the wind turbine. Obviously, we don't want to rock and roll the wind turbines and damage them, have to go out and maintain them because the platform wasn't stable enough. Other designs of platform, they tend to use an approach where the system will float stably, but it does need this, as you said, this much heavier foundation. And those structures then are moored with what's known as a catenary mooring, which is basically a big set of chains that stretch across the seabed. So there's a lot of environmental damage done by those types of mooring systems. The radius, or the diameter of that whole system can be 1.5 kilometers.
Wow.
It really is, a much bigger undertaking to use those types of technology.
Yeah, and when we put this out on YouTube or on our internet and stuff, we'll put links to your website and your stuff on YouTube, because we've seen some visualizations, and we might be able to put them in this video. We see this whole structure, as you can see on this diagram, being floated out to sea. It's difficult to concept, really, but I guess ships are a similar sort of thing, where that whole thing will be floated out to sea as it is, and then, as you say, pulled under the water, and it's that tension that keeps it stable. And we've seen some diagrams of how stable that is. So listen, thanks very much for explaining what's going on, and good luck to you. I know you're working with Swansea University as well, because I guess in this funding has to go towards a bit about how do you develop this technology, the fatigue testing of it, and the sea. Before I do move on, you said the Celtic Sea earlier. You said it's shallow and stormy.
That's right.
Yeah, explain that a bit.
So a lot of people wouldn't think of the Celtic Sea as being shallow. You think of it as being, far out to sea. But in fact, in the context of floating wind, it's actually still quite shallow. So the depths of the projects that we're dealing with here in the range of 80 to 120 meters deep. Which kind of, to some people that might sound really deep, but actually in a global context, that's pretty shallow.
Yeah.
And what that does is it introduces stability problems, because you've got big waves and not much water. So you've got a lot of water movement, and it just makes tethering or mooring these big platforms surprisingly difficult.
Yeah.
Our technology, we've developed a unique mooring system that really does make all the difference for being able to economically and safely exploit the resource in the Celtic Sea.
Yeah.
I mean, the Atlantic is a couple of miles deep. A lot of other places around the world, the water gets to, several hundred meters deep, within a very close distance to shore. So the UK and the Celtic Sea, it falls into this category of shallow and stormy, and that's a tough place to put these floating platforms. But MPS, we've got the answer to that challenge, and hence why we're confident that we'll be a big part of the technology picture that gets deployed in the Celtic Sea. Yeah,
well, good luck and power to your elbow. I know there's a bit of way to go, but hopefully the funding makes a big difference to that. Cam, before we finish, I just want to come back to you, because Graham then talked about using strip steels as opposed to plates in this in the sort of platform foundation piece. What sort of changes are required in our business? Firstly, can we make those types of steels in an electric arc furnace going forward? And secondly, do we have the capability through our existing casters and hot mill to make these processes? And what sort of opportunity does that give our business commercially going forward?
I think that's the benefit with this type of system. Post-transition in an electric arc furnace world, we do have the capability to produce the grades that are needed to support this type of structure. And working with Graham and the team, what we're looking to do is work within our current dimensional capability, both on the hot strip mill and then downward in Llanwern as we decoil these products, because we'll be applying a flat sheet into the projects. So that's the benefit. We do have the current capability to offer this, and what we're going to enhance the offering is by having low embodied carbon steel. And actually, Graham touched on it earlier, but we're already talking to wider stakeholders such as DESNES, DBT, on policy landscape changes to support the reduction in embodied carbon that these structures are going to have to withstand, and also to begin that process of consideration around that circular economy, because we are an outlet for scrap steel, and we need this industry and government and local and regional stakeholders to be made aware of. So no, I'm really ambitious about what our plans are in this space, and working with partners like MPS is vital to our success.
Yeah, and you were saying to me earlier, Cam, that if we could look forward, say, 5 or 10 years, the landscape of Talbot could change quite dramatically. And I know people say, I know I'm home when I go past the blast furnaces, but in 10 years' time they may say, I know I'm home when I drive past the wind turbine factory. Is that how it's going to look?
I absolutely think it will. And the biggest passion that I have going forward is ensuring that when someone asks us in 5 years' time, is there any steel in those big structures that we're seeing at the port? We can say, yes, there is. And that is why it's so important we do this work now, because over the next 2 or 3 decades, we are going to be seeing these huge structures being towed out into the Celtic Sea.
Yeah, listen, thanks very much, Cam. So it's a hell of a story, and I know it's kind of relatively early days where these guys have been working on this for some years, but the funding from Innovate UK will help push it forward. The vision is clearly there. The opportunity to use local steels, local supply chains coming out of Tata Steel's Talbot Steelworks for use in floating offshore wind, which is a massive opportunity to increase renewable energy, let alone use green steels from electric arc furnace, is absolutely enormous. And it's a hugely exciting vision. Yes, it's a few years away, but these things take a bit of time. And I think everyone should feel good that these sort of things are on the planning table. They're part of the vision for the future. They tie in with other industries such as ABP, such as the Celtic Freeport, to create a brighter, greener future for the Put Talbot region. So, Cam, thank you very much. Graham, thanks very much for having us in. We'll certainly be following it up and see how it goes. But good luck with the Innovate funding, and I hope it goes well for you.
Thank you, Tim.
So there you have it, another fantastic discussion about a different aspect of decarbonising the UK steel industry and talking a bit about that circular economy, the potential to have floating offshore wind on the coast of the Port Talbot steelworks, made out of Port Talbot steels, generating electricity that can be used back in an electric arc furnace. It's a fantastic vision to have. The funding from Innovate UK will certainly help that to come forward. And yes, it might be a few years away, but in tying up with things like the Celtic Freeport, the inward investment that ABP and Lanzatech are talking about, surely this is a vision for a brighter, greener future. I hope you enjoyed today's podcast. If you haven't already, please subscribe and you'll get it direct to your feed. Like, comment, let us know other topics you'd like to talk about. But I hope you enjoyed today's session and come back next time when we'll be talking to more people about decarbonising the UK steel industry.